Assalamualaikum and very good morning. My name is Ahmad Nukman Jamaludin. This is the Bachelor Degree Project 1 for Faculty of Mechanical and Manufacturing and Engineering Technology. And my SD is Dr. SETYAMARTANA, PARMAN. My title for the SEM1 is Manufacturing and Testing of Composite Vehicle Protective Helmet from RAMIE Fiber with reference to Malaysian Standard Certification. In this presentation, we will cover introduction, literature review, and methodology. What is natural fibers? Alright. Natural fibers is a one of environment enforcement material in polymer material components. Example is with cement and polymers. Okay, what is the purpose of this for my title? First is to fabricate or woven RAMIE. Second, RAMIE fiber as reinforcement. And third, to build chemical-free protective helmet. Next is problem statement. Synthetic fiber is well known for its high strength application, but it is also well known for destroying the ecosystem. This is because synthetic fiber is non-biodegradable and take a long time to degrade. Synthetic fiber process and overuse resulting in carbon pollution. Next, use lot of energy. And lastly, damage the environment by emitting huge amount of chemical waste and carbon emission. So, what is the research objective? The research objective is to design and improvise vehicle protective helmet using CATIA software. And secondly is to fabricate a protective helmet using natural fiber, which is woven RAMIE fiber. Based on the research objective, we conclude the scope of research, which is number 1, selection of natural fiber. Number 2, to design a protective helmet. Number 3, to fabricate a vehicle protective helmet using hand layout process with epoxy resin. Now, we will go to type of natural fibers available. Number 1 is RAMIE fiber. RAMIE fiber primarily utilized in manufacture of fabric, and it is one of the oldest fiber crop, has been used at least 6,000 years and found largely in China. Its mechanical properties is higher heat resistant, tensile strength, and modulus. Next is jute fiber. Jute fiber history is in manufacturing industry, which is in automobile, in building, the car seat, car dashboard, and many more. It is largely found in Bangladesh and Bengal, India, and was a cost-effective option because it is expensive plant fiber with a good tensile strength. Next is sisal fiber. Sisal fiber most widely used in natural fiber, found largely in Tanzania and Brazil. The leaf of sisal fiber is made into hard fiber. Next is bamboo fiber. Bamboo fiber is the one world toughest and fastest growing plant, found largely in China. Bamboo is used in the bamboo industry to manufacture craft, furniture, plywood, bamboo wood, composite, and other products that take advantage of the strong material feature of the bamboo. Next is coil fiber. Coil fiber is made from a coconut husk. Rope made of fiber dating back to the early 1800s years before, and coil fiber extraordinary strength has been the fundamental reason for rope manufacture for the centuries. It is also a low cost absorbent option that can eliminate uh, chemically heavy metal ions such as nitric ion and ferrum. Okay, now is the mechanical properties of natural fiber. From the previous research, it shows that RAMIE fiber has the highest tensile strength and young modulus compared to jade fiber, scissor fiber, bamboo fiber, and coil fiber. In this lesson, we will using specialization uses the improvement of woven RAMIE fiber mechanical properties. RAMIE fiber is an excellent reinforcement material for resin composite with its antibacterial and anti-corrosion properties. This is the table of mechanical properties of RAMIE fiber reinforced with epoxy resin. As we can see, the tensile strength is 46 megapascal and the young modulus is 6.59 plus minus 0.68 gigapascal, and flexural strength is 103 megapascal. Okay, now is the manufacturing method for natural fiber composite. The first is hand layup. Composite, the first one is hand layup, which is the manual method using roller and AB resin. Second is spray layup. Technique is compression molding that using molding machine. Number 4 is filament winding using a revolving mandrel, and number 5 is injection molding that use heated barrel. And as a summary, we will using hand layup, which is using roller because it is inexpensive and simple to be conducted. Now we're going to topic of protective. In the year 2012, the updated helmet standard formulation designated MS1 2011 were formally published and made public. And the helmet that being manufactured in Malaysia must follow the Malaysian standard. In Malaysia, they have two standards that regulate vehicle protective helmet, which is number 1 is MS11 2011 Protective Helmet and Visor for Vehicle Users Specification Part 1 Protective Helmet, and number 2 is for Visor. Vehicle Protective Helmet Requirement. The following statement is based on Malaysia Standard Code MS11 2011. As you can see here, this is the general construction for the helmet. Minimum extent of protection, as you can see in figure 2, the helmet must pass this area to fulfill the requirement. If you are following the Malaysian standard requirement, this helmet can be used because it does not pass the required minimum requirement, because this helmet did not protect the neck area and known as the tail helmet. Only this kind of helmet can be used because it protects the neck and pass the requirement for Malaysian standard. Okay, next is what is the formal requirement test that based on MS11 2011. The first is the helmet must goes to resistance to penetration test, strength of retention system, projection and surface friction test, and rigidity test. And next is methodology for question 1. The methodology will explain about technique of fabrication on safety helmet using RAMIE. Number 2, process and procedure of fabrication. And number 3, how the project being conducted. This is the flowchart of the project. And for the material selection, we will be using 5-layer RAMIE composite because in previous research it showed a high tensile and fractural strength. So 5-layer of RAMIE fiber is used as the main material to fabricate our safety helmet. As you can see from here, the mechanical properties for tensile and fractural properties of 5-layer RAMIE composite. Next is material preparation. The material preparation is the RAMIE fiber was spun into yarn, which was then woven into RAMIE woven using a weaving machine. And we will using epicyresin A plus B as the metric for the composite. And for the 3D preparation, we will be design the helmet using CATIA software. And this is the drawing of the helmet. Okay, that's all from here, and in the upcoming SM2 we will fabricate the helmet and test the helmet by following the Malaysian standard requirement. Thank you, that's all from me.